am afraid that GPT-5 or GPT-6 or GPT-7 might be the Titanic.
Believe it or not, William is the first OpenAI employee that we've had on the show expressing criticism of OpenAI from within, or like from previously within.
What people were talking about at the company in terms of timelines to something dangerous, a lot of people talking about similar things to the predictions of Leopold Aschenbrenner, 3 years towards wildly transformative AGI. I was leading a team of 4 people doing this interpretability research, and we just fundamentally don't know how they work inside.
We also fundamentally don't understand how dogs work inside, but it does not mean that we should be scared of dogs causing an extinction-level event in about 5 to 10 years. By the way, it would be more informative and honesty to call models like ChatGPT a machine learning system than an AI system. Yes, machine learning is under AI, but the way companies are throwing around AI is quite misleading because the current crop of models aren't even close to the goal AI initially sought out to achieve. Anyway, the fundamentals of machine learning are quite simple. What is hard is to step through a trained model, even with few parameters, to track and explain how inputs are transformed into outputs. It's cumbersome because neural networks are distributed models. Imagine if I gave you a pixel grid of floating point numbers. You wouldn't know what those numbers mean. But if I converted that pixel grid into light intensities, then you can see it's a picture of a dog, for example. It's a matter of information format. In neural networks, information spreads out throughout the network, and us humans are visual creatures. We understand images, but not floating point numbers. Hence, any system full of large numbers is just hard to explain verbally. That doesn't mean artificial neural nets, ANN, can suddenly become super intelligent and that we should be scared of them. So I am not sure why people would be concerned about such models becoming suddenly sentient or more intelligent than biological systems. Statistical learning cannot result in intelligent machines no matter how massive the networks trained are. Essentially, yes, it's hard to step through a trained network to explain how the inputs transform into outputs. But the fundamental building blocks of these models and how they are trained suggests they are not capable of intelligent behavior no matter how big they become.
Unlike any other technology known to man. If you have the blueprint for building something as smart as a human, then you run a bunch of copies of it and they try to figure out how to improve the blueprint and make itself even smarter.
Current machine learning systems are in no way comparable to human intelligence or anything close to that, for many reasons, and one of them is energy efficiency. True intelligence is supposed to solve problems using the least amount of compute, energy, space, time, and resources, because the longest surviving system in time of scarcity will be the most efficient system. If something needs a ton of energy, like current machine learning models do, then it must solve the problem of getting all that energy, which is natural scarce to survive. If anything happens to the supply, then it dies. Such a system can be pretty easy to defeat. No need to be scared of such a system at all. A cockroach can survive off licking fingerprints off of stuff people touch. If that is not scary, then I don't know what is. Just see how difficult it is to get rid of cockroaches. I would be more scared of a system that can weather very bad conditions. Not to mention in warfare, the military machines must be robust and efficient, so if energy supply go very low, the systems are supposed to be functioning. And for space exploration, you want efficient too. Therefore, any system that must survive in the real world is intelligent by default, efficient by default, because that's what is required to survive the longest. To be efficient, it won't survive for long. Intelligence is about finding the best solution with the least possible computational complexity in space and time. That's an approach that's orthogonal to today's AI systems. It's all about efficiency. An effective system has to be able to fall back to progressively efficient low-energy modes as resources become increasingly more scarce. Like mobile processors have low-energy cores. In fact, the brain has a low-energy mode too. Truly intelligent machines will need such a fallback strategy. In time of abundance, it's okay to be less efficient, But as resources plummet, the best system must shift into low-energy modes, which would also require efficient algorithms running there. So no. Today's AI systems are in no way intelligent, and we're nowhere near close to building systems that are truly intelligent. New approaches, paradigms, and major breakthroughs are needed not only in the field of artificial intelligence, but also in computational energy efficiency. We're far from achieving human-like intelligence with current ML systems, and addressing these challenges is not going to take mere 3 years, but decades and decades, or even centuries.